Hello students, here I am working on a video. I'm making this video on lesson number 5, Algebra 2 Unit 5. And the topic of the lesson is scaling the outputs. So now when you go down here, what is the learning target here? So the learning goal is we can calculate the scale factor k needed to transform the outputs of a function to fit the data. Also, I can calculate the scale factor needed to transform the output of a function to model the data. Now, if you see today in the class, we try to figure out what. So there was this arch shape parabola, which is from the left to right of the bridge, and then we figured it out that how to figure out what is the scale factor. Just let me refresh what we learned. So if you see, this was what we did, and the way it is, the end of the arch are 52 apart. So this was 52, and then we have see halfway down is 26 is somewhere here, and therefore if this is 26 and the height of the how high it was 25. So if this is 26, then this was 25. And then this is distance was 52, so this is 52, and 0 starts at 0 0. So the first base of the arch, this arch base, we begin at origin. And then we also seen how to, so the question was which is the best suitable equation for this. The one student, Mr. Hand says, so that one student says he creates an equation and so he writes it as x and 52 minus x, which is because he thinks this is the zeros 52 and 0. So using the factor form, he gets this equation. But the question is, when you plug this 0 right here, when you put 0, you get 0, and when you put 52, you also get 0. So these two take care, but when you plug in 26 here, you end up getting 676. So you can always check that, and which is way high, too high for this parabola. So it doesn't fit this arch. The maximum height is 25. So this 676 is very high, and that's what it is. So it's something like this way maybe. So we needed to get this point, which was exact. So if I try to draw dotted like this, so that is like height is 676, and this was 25. So this height is 25. So now we need to squash. We need to squash means we need to shrink this point towards this point. And the only way to do is, I asked the question, what multiplies? So what multiplies to 676 to get to 25? And because we don't know, I can always put some letter alpha. And then you divide by 676 both sides. And you get alpha equals a fraction which is 0.036, and that's what we have to use. This is what we have to use. This equation we have to rearrange and write, okay, better we have a 0.036 and then times and then 52 minus x. So that's the only way. If you try to rearrange this equation, this one, then and when you plug h equals, let's say this point 26, and you will get answer is 25. So this is the scale factor. So what is this alpha? This is the scale factor. So the scale factor is used to bring this point all the way down. So you're like shrinking. So this is shrinking. So you're shrinking, or also you're compressing. So how this happens is because this scale factor that you see is smaller than 1. So anything is alpha of the scale factor. You can call it like instead of alpha, you could call it also like k, let's say. So the new function, so this one, so this was the actual one, and this was what was the, maybe if this was hx, so we need to get hx, so the new one, so this was the old hx, so now you have to get another one, h1x. So this, let's call this one is h1 because this is a new one. So how do we write is the h1x is that 0.036 times the hx. That's what it is. That means the output of this function will be same as once you multiply the scale factor this, then that point which is up here will go down. So it will shrink right here. So that was what we did, and let's see how to apply this in similar different situation. Now this problem, so here I'm working on the practice problem of lesson 8 and unit 5. So the first question, so there is, in each of the pair, if you see, there is a dotted graph and there is a the solid graph. The dotted is the original graph, that is fx. You can see this is fx. Here the dotted is, this one is the fx, okay, and here there is fx. So the dotted is what is the original graph, and the solid is the new graph. So the question is, how did you get the solid graph from the dotted graph? So I'm going to take two at a time. Let me pull this up. So the question is, in each of the pair, the values of the function g are the values of f, that means the output, multiplied by. So some scale factor is multiplied. So what is that multiplies to this minus 1 going to get minus 55? So let's see how to do this. Okay, the first question is, watch this part. I'm working. This is the So the question is, let's see, I'm gonna draw the f of this. So the solid, the dotted one is, so this is the dotted one. Okay, so this is the original graph, and the main thing is it has a vertex, and the vertex is right here. This point is given to you, and then the gx, the other one is the red graph. So we need to know, how do I shrink that? Now you can see the red, the blue graph is down, so this graph has to go, or this point has to shrink, or it has to be squashed towards to this point, right? So the y coordinate here is negative 121, see, and the y coordinate here is negative 55. So we have to bring this output. So what multiplies to 150? The best way to do is what multiplies to 121, so that your answer output is the red one is to get negative 55, because the red one is this one output is given there, it is minus 55. So how do you get this? So the only way to get this, because you don't know, let's put it like a k, that's a scale factor. So we want to know, so just divide by 121 both sides. So when you divide 121 both sides, this crosses out and you get k equals positive, because there are two negative, and you can see 5 divides 5, 55 11 times, or you can say 11 divides 5 times 11 times 5 is 55, and 11 times 11, so we can reduce this to 5 divided by 11. That's the scale factor. The question was, what was the scale factor? So the scale factor is 511, and this 5 by 11 is smaller than 1. So whenever there is a smaller than 1 means, so the f of x graph is shrinks. So you can use either word shrink or compresses. So it compresses or squashes or squash. They say the other word you squash by a scale factor k, which is equal to 5 divided by 11, and you're done. That's all they're asking you. So every point, let's say this point goes right here, this point will go right here. So it's like there's a vertical compression. If you see the second question right here, look at this question. This is the original is minus, so this is, so you have the original is minus 8, and that minus 8 goes down, which is 0 and minus 13.6, right? So this is the old one, this is the new one. So the best way is, what multiplies to here minus 8? So I'm asking a question, what multiplies to negative 8 to get negative 13.6? So it's always the k is basically scale factor is the always the new divide output over old output. So this minus 13.6, you just divide by minus 8, and you just little of calculation, 2 negative makes it positive, and I think it is 1.7. I think it is 1.7. So you get the answer 1.7 and you are done. So this is scale factor is 1.7, which is greater than 1. What it means is, so the f of x graph, the dotted graph, so this dotted graph which you see that is there is a vertical, so there is a vertical, or you can say stretches. So here you say stretches vertically, okay, vertical. So let me write it nicely. So we say, so how do you get gx? The gx graph is obtained by when the f of x stretches vertically. So this is the nice way to write down. Make sure you write this by what scale? By a scale factor, and that is k equals 1.7. That's it. You're done. Let's do the third one and the fourth, because there are 4 of them. Now in this case, the dotted one, look at the dotted one, the blue one, this is the dotted one, and you can see the dot that is they gave us is, this is the point, which is, this is the old one. So this is the old output, which is minus 50, and the red one is the new one. So this point, which is right here, this, so that's this is the old, the new one. So you have to, and you can see the point which was down, so kind of, so that one, it shrinks. See this, it goes down up here, right? So it's like a shrink. So it has to, and you can see the red, this is the one. So after shrinking, it goes like this. So there is a vertical squash or vertical compression or vertical shrink. And then we need to know what is the scale factor. So the scale factor, now that we can write directly, the k is the new is negative 12.5. That's what is you see here. And you divide by the old one, which is the blue color, minus 50. And if you see this, use the calculation, you will see this is positive, and this is like 125 divided by 500, and which is nothing but 1/4. Or you can just see this 12.5, 12.5, 12.5 4 times. If you multiply 4, you get 50, and that's why it is 1/4, and you're done. That is less than 1, so it shrinks. If you see the next one is asking this point, which is right here, but then you have it is the solid one, the gx is down, so there is some kind of a reflection. So we need to think of the original function, this f of x, there has to be minus of f, but then before that we need to do something, has to be multiplied. So it has to be, because this distance, like let's say this distance is negative 1.5. So if I want to see to get the dotted one, this dotted one, I want to get it first to this one. So can I bring it like this? See? So first let me do this way, kind of this maybe. So this point first, not that, I made a mistake. I think it should be, because it is almost negative 1.5, I want to get 1.5 right here, so the point will be this reflection. So your new, this will be your, we want this graph first, okay, something like that. So from here to here, I have to change f of x. So the first thing is the first step one, let's see, step one, you kind of, you shrink this point, like this is like from here, this is 1.5, right? So by what factor you get this all the way down? So it is going to be k 1.5 divided by 6, and because the output here, this output is 1.5, and that is at 6. See this point? So 1.5 divided by this is the old one, and the formula is the scale factor is the new. So it is the new divided by the old, and if you do this, this is 15. Multiply 10 numerator denominator, you get 60 and you get 1/4. So basically the first step is step one is you first get this pink color, and that is 1/4 of f of x. So that's the first. Then after this part, you kind of multiply by minus. So it's because you want to reflect over the, so this is over the x-axis. So that means if you have f of x, if you want to reflect over the, you have to do minus f of x. The output has to change. So this is going to be your gx. That's all you're supposed to write. One is the scale factor. Okay, not this. The scale factor here, this scale factor is only to shrink, but then you have to also reflect. So you first shrink this by scale factor of 1/4, and then you reflect over the y-axis. So your gx is minus 1/4 of f of x. So whatever that f of x, you have a vertical compression of by a scale factor of 1/4, and then this minus means you reflect over the y-axis. Hope it helps. Let's go to the next question. So here is the graph, cubic graph given, and you can see there's a graph there. Will scaling of outputs of f change the x-intercept of the graph? Explain how you know. Now what it means is, remember the output, when we talk about the output, when you change x, let's see if there is a point x1, y1, and when you change this by, you use a scale factor and multiply. So x1 stays the same, and the y1 is k, so the y coordinate, the output changes. So this output stays the same by the definition, or when you have a vertical, stretch or shrink, this x stays the same. So here the answer is no, because when you pull something up, let's see, if I want to pull this point right here, which is looks like it is like a 3, this 3, if I use a scale factor of, let's see, k equals 5, so the 3 because 5 times 3 is 15, so the x coordinate here is 0. So this 3 will move to 15. Where is 15? So this is the 15. This will go up here. So this point, let's see if there was another point, and let's see another point. This point is at 3. So this is like a 3 is 10, but when you multiply 10 times 5 by scale factor, you get 50. So that means this point will move somewhere. This is 10, this is 10, 30, 40, and somewhere 50 here. So this point will move like this. So the new one will be, so this one, because the y coordinate is already 0, so that point will remain the same, and it will look like it goes this way. So it stretches up, and then this point y coordinate stays the same. Then it will go like this, and then it goes. So basically this point moves up, and that's how it is. See? So the second question, will scaling the f change the y-intercept of the graph? Yes, the y-intercept. Look at this 10. Now it is 3 is 50 because I chose 5 as the scale factor, and 10 times 5 is 50. So you get, so that's the 50 right here. So the output changes, but the x. So this is no, and this is yes. I hope that helps to understand. Will scaling the outputs of f change the y-intercept? We change the y-intercept of the graph. The y-intercept basically because they are on the point, the y-intercept will not change. Let's say this point is 1.5 comma 0. So when you multiply by scale factor, the 0 will remain the same place. Anything multiplied 0. This anything on the sorry, will scaling the output of change the y-intercept of the graph? Yeah, so if it is this point, look at this point is the y-intercept. Sorry, not that one. Let me do one more time. What I'm saying is almost there. So this is 3. This is 3. So if I want to scale it by scale factor of 5, it will go 5 times 3 is 15. So this will, the output changes. So the y-intercept will change to 15. That's what it is. So this goes here. Okay. So that is yes, because, and you can write this answer. This is 3. This is 0, 3, and this is 0, 15. So 3 goes to 15. So you are given, this is the third problem. You are given an exponential function, and you know what that means is it grows. We have a graph. Exponential function y is 2 raised to x. When x is 0, it goes through 1. 100% goes through 1. And if you want to find 2, 2 goes to 4. So somewhere here. So this graph is something like this. Okay. So it is like 2 goes to 4 and something 1 goes, 0 is 1, 1 is 1, like that. So the point I'm making here is 1 is 2. So this is like 2. Maybe this is 2. This is 1 here. So question is, while the function g, so there's a new function, and you can see there's a 4 multiplied by just looking at it. So they gave you the new function graph is 4 times 2a raised to x. Now what that means is both students are arguing on, Kiran says the graph of g is the vertical scaling of f. And he says, yes, it's correct. He's saying, because there's a 4 there, this 4 is greater than 1, that's like a k, and scale factor is 4 greater than 1, so there is a vertical scaling of, so vertical stretch of f by, and by how much? By a scale factor of 4. So Kiran is right. So every point, let's say if this is the point, this will go 1, 2, 3 and 4. So this will go to, sorry. So if this is 1 and this is 2, 3, 4. So this point will move here. So the graph, the graph stretch goes something like this. So that's all. But there's another student who says, mine says the graph of G is horizontal shift of F. So what she's saying is, so let me do it one more time. What Mai is saying is, this is the original graph, but what Mai is saying is, this student says, is shift horizontal, let me say the graph of G is the horizontal shift of the graph of F. So is she correct? So what Mai does is, watch this, we need to do some work here. So this could be written as 4 is 2 square, so I can write it like this, 2 raised to x. And now they have both bases are the same, so I can write it as 2 same, and then this 2 and x, because by the laws of the exponent get like this, which is 2x plus 2. And you can clearly see, because this is x, there is a plus 2. What that means is there is a horizontal shift. So it shifts horizontally 2 places left. So it means 2 places unit to the left. So both are correct. So either first one says, Kiran says this graph is moves up 1 like that, 2, 3, 4 like that. It goes like this way. But then what Mai thinks is this graph can be shifted maybe 2 places to the left. So when you shift this 1 and 2, then it goes the same graph. It's the same thing. See? So I may have not done this properly, but what it means is this is the graph. You can also check this graph uh, by, if you want to use, yeah. So you can use even the Desmos. You can put on the desmos.com when you get time. Put this equation and put this equation and put this equation, and you will see the graph will be the same. So it means either there is a vertical stretch by a scale factor of 4, or the original graph shifts 2 places to the left. So there is a plus, so you do the opposite, 2 places to the left. Okay, question number 5, straightforward. They did give us that f is an odd function, and remember what is the meaning of odd function means. If there is a let me take this cubic function. Means if you have a cubic function like this, and if there is a point, let's see 2 and 8, then the other side is a reflection. So every graph, odd means any point on this point, and there is a reflection on, so there is that reflection on the other side. Maybe I have not drawn it correct. This is the correct one now. Okay, so that there is that. So this 2, 8 becomes right here, reflects on the other side, becomes -2, -8. So if you want, if the graph is odd, then when you do the opposite input, if this is 2 and there is a -4, the output also becomes opposite. So that's all you're looking here. So if you see the table right here, there is a 3 is negative 11. So it has, then the negative 3 has to be opposite. So this has to be opposite plus 11. So if this is negative 2 and 5, so opposite of negative is plus 2. So this has to be negative 5. And then the last one is, this is 1 is 19 plus 1. So -1 is opposite of plus 19 is -19, and you're done. Of course, there's one more here and here. So this become -4. This will change to +3. So just change that. That's it. So the last problem is 6 is here. This is you're given a cubic function, the dotted one. There it is. This is the dotted one. Okay, so that's the dotted one, and they gave you a point, which is this point, and a graph G is given, which is the transformation of f. So the question is, what did happen? Now, when you talk about transformation, means left, right, up, and down. So if you see this dot, so first step is, this number is -1, and so this is -1 and -4. So what it work out is that it goes to the left. So this is 1, so it goes to the left. So the original graph, the dot, this red dot, or let me use the blue color then. This blue dot moves one place to the left, right in equations, right? So you want to write gx, so you have to move this graph, which is x cubed. So it has to move to the left, so I have to use x, but I have to write +3. See, raised to 3. So this is because the graph first goes to the left. That means this graph is something like this. So it moves to the left first. Okay, this is where it moves. That's the point. And then it has to go down. So now I have to move it down. So let me use this color. So it has to go, it goes 1, 2, 3, and 4. So it goes 4 down. So when it goes 4 down, you get this, it translates, or it shifts 4 units down. That means you have to write -4, and you are done. So that's it. Or you want to write in the form of function notation, you can write gx is f of x plus 3 and then -4, and there you go, done. Hope this helps. So this is, I'm finishing practice problem, lesson 8, unit 5, algebra 2. Okay, so the next video I'm making is for 9. So stay tuned. Make sure you write all the work so that you get good points.